In this question, it is given that define the collections E1, E2, E3 and so on of ellipses and R1, R2, R3 and so on of rectangles as follows. The equation of ellipse E1 is this. R1. R1 means rectangle of largest area with sides parallel to axis and inscribed in E1. En means ellipse this of largest area inscribed in the rectangle Rn-1 where n is greater than 1. And Rn means rectangle of largest area with sides parallel to the axis inscribed in En where n is greater than 1. Then which of the following options is oblique are correct? You have to find the correct choice. According to question, this is the ellipse and this is the rectangle inscribed in this ellipse whose sides are parallel to the axis. And then he says that we again inscribe a ellipse of maximum area in this rectangle, and the name of this ellipse is E1, name of this ellipse is E2, the name of this rectangle is R1. And again we inscribe a rectangle in this ellipse, and the name of this rectangle is R2. And again when I will inscribe an ellipse in this R2, the name of that ellipse will be E3, and in this way I go on inscribing. According to first choice, the sum of the areas of all the rectangles from 1 to capital N is less than 24 for each positive integer n. It is clear that sum of the areas will go on increasing as the number of rectangles increases. Area of R1 means area of rectangle ABCD. Area of R2 means area of rectangle PQRS. In this way, it is clear that the more number of rectangles I take, the more will be the area. And he says whatever is a positive integer n, this is less than 24. Therefore, I find the total area of infinite number of rectangles made in this way. For clarity purpose, I am drawing the diagram once again. With x coordinate of this point 3, with y coordinate of this point 2, and inside this I have made a rectangle and I want to maximize the area of this rectangle. We know that any point on the ellipse can be taken as a cos theta, b sin theta. A is 3 and b is 2. 3 cos theta, 2 sin theta. And I will find the value of theta so that the area of this rectangle becomes maximum. As this point has x coordinate 3 cos theta, the total length of the rectangle will become 6 cos theta. Total breadth of this rectangle will become 4 sin theta. Therefore, area A1 of rectangle R1 will become 6 cos theta into 4 sin theta, that is 12 sin 2 theta. Obviously, the maximum value of this is 12, and that maximum value will be attained when 2 theta is 90, that is when theta is 45 degree. Hence, area of this rectangle will become maximum when this point becomes 3 by root 2, comma 2 by root 2. And because in this rectangle I have made the ellipse E2, obviously the length of semi-major axis will become 3 by root 2 and length of semi-minor axis will become 2 by root 2. And again I have made a rectangle of maximum area inside this ellipse E2. Note that this is ellipse E1, this is ellipse E2, this is rectangle R1, this is rectangle R2. It is clear from the figure the length of semi-major axis of ellipse E2 is 3 by root 2 and the length of semi-minor axis of ellipse will be 2 by root 2. And previously when the length of semi-major axis was 3, I had got this vertex as 3 by root 2, 2 by root 2. Similarly, in the case of ellipse E2, the length of semi-major axis is 3 by root 2, then this point will become 3 by root 2 square. The x coordinate of this point will become 3 by root 2 square and 2 by root 2 square. Hence, the area of this rectangle will become 6 by root 2 square into 4 by root 2 square. Therefore, now the area will be 6. Hence, you can easily conclude that for every inscribed ellipse, the length of semi-major axis becomes 1 by root 2 times the length of semi-major axis of previous one. Hence, for every rectangle, the length of rectangle is 1 by root 2 times the length of previous rectangle. Similarly about breadth. That is why when the area of rectangle R1 was 6 by root 2 into 4 by root 2, that is 12, the area of R2 has become this. Similarly, the area of R3 will become 6 by root 2 cube into 4 by root 2 cube, that is equal to 3. In other words, I can say the area of any rectangle is half of the area of previous rectangle. That is, I can say the sum of the areas of all the rectangles will be 12 plus 6 plus 3 plus 3 by 2 and so on. And it is clearly infinite GP with first term 12 and common ratio 1 by 2. Therefore, sum of the areas will become 12 upon 1 minus 1 by 2, that is 24. That is, I can say sum of the areas of all the infinite number of rectangles is 24. That is why sum of the areas of finite number of rectangles will be less than 24, however large the value of n is. Therefore, choice A becomes correct. As you had seen that the length of semi-major axis in E1 was 3 and the length of semi-minor axis was 2. In case of E2, length of semi-major axis had become 3 by root 2, comma 2 by root 2. The length of semi-major axis in case of E3 will become 3 by root 2 square and 2 by root 2 square. This is the case of E1. This is the case of E2. This is the case of E3 and so on. Hence, in case of E9, the length of semi-major axis will become 3 by root 2 to the power 8 and 2 by root 2 to the power 8. And it should be also known to you, length of semi-minor axis is B and length of semi-major axis is A. Eccentricity of that ellipse is obtained by the formula 1 minus b square upon a square. From here, I can easily conclude that if I divide or multiply semi-minor axis and semi-major axis by same constant r, the new ellipse will have same eccentricity. Length of semi-minor axis becomes br and length of semi-major axis becomes ar. Then eccentricity of new ellipse will be clearly br square upon ar square, that is 1 minus b square upon a square. And I am going to use this conclusion for this ellipse. Initially, the length of semi-major axis was 3, semi-minor axis was 2, eccentricity for the ellipse even was 1 minus 2 square upon 3 square, that is 1 minus 4 by 9, that is 5 by 9. Therefore, E for the ellipse even was root 5 upon 3. And because for E2, the length of semi-major axis had become 3 by root 2 and length of semi-minor axis had become 2 by root 2, that is both semi-major axis and semi-minor axis have been divided by root 2, that is same constant. Therefore, for ellipse E2, eccentricity will remain same, or we can say in this way, eccentricity of ellipse E2 is obtained by 1 minus 2 by root 2 upon 3 by root 2 square, that is E square equal to 1 minus 4 by 9, that is 5 by 9. Therefore, eccentricity of ellipse E2 will be again root 5 by 3, that is eccentricity of all the infinite number of ellipses is same, root 5 by 3. And in case of choice C, it is given that eccentricity of E18 and E19 are not equal, becomes wrong choice. And we also know that for any ellipse, if length of semi-major axis is A, distance of focus from center will become AE. Using this concept, as I told you, in the case of ellipse E9, the length of semi-major axis had become this. Therefore, distance of focus of E9 from center will become 3 by root 2 to the power 8 into E. E is root 5 by 3, that is root 5 by 16. But in this case, distance of focus from center is given as root 5 by 32. Hence, B choice becomes wrong. C already has been proved as wrong. As I had proved previously, that the length of semi-major axis of ellipse E9 was 3 by root 2 to the power 8 and length of semi-minor axis had become 2 by root 2 to the power 8. Therefore, the length of lattice rectum of E9 will be 2 into 2 by root 2 to the power 8 whole square upon 3 by root 2 to the power 8, that is 2 into 4 by root 2 to the power 8 upon 3, that is 1 by 6. Hence the length of lattice atom of E9 is 1 by 6. D choice is correct choice.